Alright guys, welcome to our review for our semester 1 final. This is review day 1. I'll be going through the odd problems. Let's begin here. So this is number 1. This is a linear equation. So when you're trying to solve a linear equation, the first thing that you want to do, if possible, is distribute. Okay? So any distribution you can do, you should do it. In this case, for instance, this negative 2, I can multiply that into this set of parentheses. And if I do that, I end up with a plus 4x minus 4. With the other side of this equation here, there's a negative in front of this parentheses. So I can distribute a negative 1. You can think of it like you're multiplying by negative 1. And so that's going to make this become a minus 4x and a minus 6. Right. The next thing you want to do is you want to combine any like terms that you have on each side. So for instance, on the right side, these two terms are like terms, and I can combine those together, and they just cancel out. It doesn't always happen like that, but in this case, they actually just cancel each other out because they're opposites. On this side, we also have some more like terms, the 6x and the 4x. Those can combine. 6 minus 4 is 2x. Okay. The next thing you want to do is just start getting the x by itself. Now, but before I start doing the next step for this problem, though, sometimes you'll have an x on this side still. Like, let's say, for instance, don't write this, but let's just say I had a plus x here. Well, you would need to subtract x on both sides first. And that step is called moving, like, move the smaller x. What do I mean by that? I mean, like, this side has an x, this side has a 2x. Which one's smaller? Well, x is smaller than 2x. So what I would do is I would minus x on both sides. That way we get x on only one side of the equation. But in this particular problem, we don't have that. But I wanted you to be aware of it because it might be on one of the problems you're expected to do. So I'm going to go ahead and cross that off, but it might be nice to have at least on your notes, even though we're crossing it off, so you're aware of it. But after that, we just solve for x using some good old-fashioned Algebra 1. So how would I solve for x at this point? I would add 6 on both sides. Now there's only a 2x on the left side. And then I would divide both sides by 2. And my answer is 1. Okay? So that's solving linear equations. You could see more examples and more help if you want in your 1.1 notes. Let's go ahead and move on to number 3. We have another problem to try out here. So same steps as number 1. So if you want to see the steps written out in words, go ahead and look back at number 1. But here, we're going to start with the same first step, which is to distribute first. Then the next step is to combine like terms. There are no like terms on this side of the equation, but we do have like terms on this side. On this side, there's the 8 and the negative 12. We could put those together. So negative 8 take away 12 is negative 20. The next step is to move the smaller variable. Now in this case, they're both the same, so it doesn't matter which one you move, just pick one. I'll go ahead and add 4a on both sides. Since it's a negative, right, you always do the opposite. And in this case, they both cancel out. Now that's a weird situation. When the letters go away completely, you're just left with a numerical statement with no variables in it at all, just numbers. If it's a true statement, that means that the answer is all real numbers. In other words, x could be anything. I'm sorry, in this case, a. A could be anything. You could pick any number you want to for a, and it will always be a good answer for that equation. That's if you have a true statement. If you have a false statement, then there is no solution. So in this case, is this a true statement? Negative 20 is equal to negative 20? Yes, it is. That's a true statement. So my answer is all real numbers. So in other words, a can be anything. Now, this is a quadratic equation here for number 5. For quadratic equations, they always have to be equal to 0 before you can solve it. Now, we've learned 2 methods for solving quadratic equations. One is factoring, and the other one is the quadratic formula. On this problem, they want me to factor it. So I'm going to do this box method for factoring it. Why would I do the box method? Well, because it's got 3 terms. When you have 3 terms, you do the box method. The first term goes here. The last term goes here. And then we're looking for numbers to go on the outside of the box. These 2 numbers should multiply together to make v squared. That would be v times v. These 2 numbers here should multiply together to make negative 40. What would that be? I've got to ponder for a second here. So let's try 10 and 4, which is probably what most of you guys are thinking. Now I'm going to say don't write that though, because I already know it's not going to work. All right? But I want to show you why I know it's not going to work. Okay? So what we do is we fill in our box. V times 10 is 10v, and 4 times v is 4v. Now we know that we're right if these 2 numbers here can combine to make 3. But there's no way that 4 and 10 can make 3. You can't add them to get 3, and you can't subtract them to get 3. So when that happens, you have to try a different guess. There's a couple things you could do to try a different guess. One thing you can do is you could just switch the 10 and the 4 around, but that's not going to help me because it would give me the same answer. So what else can we do? Instead of doing 10 and 4, we could try a different pair of numbers like 8 and 5. 8 times 5 also makes 40. Now, can these 2 numbers add or subtract to make 3? Yes, they can. If I have a negative 5, then 8 minus 5 gives me 3. So that means this 5 has to be negative, and this 8 has to be positive. So we have v plus 8 and v minus 5 is the factored form of that trinomial. We got those from the outside of the box there. The next step after you do the box is to set each one of these factors equal to 0 and solve. So v equals 8. And v equals 5. And that's it. Number 7. We're going to factor again. But this time, it doesn't have 3 terms. So we're not going to use the box method this time. Instead, we're going to use another strategy known as the difference of squares strategy. For that one, you just take the square root of this, which is x. You take the square root of that, which is 5. You make one a plus and make one a minus, and you're factored. Those ones are nice. The next step is to just set each factor equal to 0 and solve. And we have two answers, 5 and negative 5. Here's another one we want to solve by factoring. Once again, this is not a box method, but it's not a difference of squares either, because you can't take the square root of n. We can take the square root of n squared, but you have to be able to do the square root of both in order to do the difference of squares. This one is actually a GCF. So what I've done in the past three problems, 9, 7, and 5, is I've shown you three different factoring strategies: the box method, the difference of squares, and now this is the GCF method. So you have to know those three strategies and when to use them. The box is if you have three terms. The difference of squares is if you have two perfect squares being subtracted. If it's neither one of those, then you should look for a GCF. In this case, what can I divide out of both of these? Well, they both have an n, so I would take an n out. And if I take an n out of this one, then instead of having two n's, it will only have one. And if I divide this one by n, we're left with 1. Okay? Anytime you divide something by itself, you get 1, right? After you factor it, you set each factor equal to 0. So n equals 0, and n minus 1 equals 0. So for this one, there's nothing to do. The answer is 0. But for this other one over here, we do need to add 1 on both sides. And there we go. So 3 ways to solve quadratics by factoring: box method, difference of squares, and GCF. Got to know all three strategies and when to use them. Now this one's different. It looks a lot like the one we did in number 5, but the directions tell us to do something else. Instead of factoring, this one's asking us to solve it using the quadratic formula. Factoring is cool because I think it's easier than the quadratic formula. That's just my opinion. But the problem with factoring is that it doesn't always work. Quadratic formula always works, but the reason I don't like it is because, in my opinion, it's a little more tedious. So, first of all, the quadratic formula is this thing here. That formula will tell you what x equals so long as you have a quadratic formula in standard form, which looks like this, and it's equal to 0. Okay? In this case, the a is 1, the b is also 1, and the c is 4. Actually, the b is negative 1. So the first thing that we're going to do is we're going to plug those numbers into our quadratic formula. So b goes in the first two spots, and my b value is negative 1. A goes in the next spot, that's a positive 1. It also goes on the bottom. C is 4, and that's the last number I'll plug in. Now I'm going to simplify 4 groups of numbers here. We have this guy, which is 1. We have this one, which is also 1. Then we have these 3. 4 times 1 times 4, which is 16. And then on the bottom here we have 2. All right, next thing we're going to do is we're going to take care of this square root that we have here. I'm going to rewrite it real quick. All right, so let's take care of this square root. The square root of 1 minus 16 is the square root of negative 15. 1 take away 16, negative 15. And since we have a square root of a negative number, we're going to take that negative out and put an I on the outside. The next thing we're going to do is we're going to break it down. 15 is 3 times 5. And if we have any pairs, we'll take it out. But as you can see, we don't have any pairs, so I can't take any numbers out. And so it's really just going to stay as I square root of 15. That's what I'm going to put right here then. The next thing you can do, if possible, is reduce. Now, I cannot, and here's why. You can only reduce if this number, and this number have something in common that they can be divided by, but they don't. So we'll just leave our answer like that, and that's as good as our answer gets. Okay. Let's go ahead and take a look at another problem, number 13. And so for number 13, we have another quadratic formula problem. This one turns out a little bit different, has a few extra steps in it, so that's why I included it. The A is 2, the B is 8, the C is negative 12. So let's go ahead and begin. All right, so the B is 8, the A is 2, the C is negative 12. That's just negative 8. That is 64. Those three numbers multiplied together make negative 96. And these two make 4. Next thing we're going to do is we're going to simplify our square root. I'll do that off on the side here. First of all, the double negatives can be written as a positive. Second of all, we can go ahead and add these things together here, and I believe we get 160. Next thing we'll do is we'll go ahead and break this down. 160 is 10 times 16. 10 is 5 times 2. 16 is 4 times 4. And both of those 4s break down into 2 times 2. Oops. So the 60 broke up into 10 and 16, which broke up into other numbers, and we're left with these numbers, which are the prime outcomes. So underneath this square root then, we have a 5, and we have 5 2's. Now this is a square root, so we're taking out groups of 2. So for every group of 2, we can write that number on the outside and cross off the pair on the inside. That's a 2, it's not a 3. So we have 2 times 2 on the outside, which is 4. And on the inside, we have 2 times 5, which is 10. The rest of the problem comes down as is. The last step is to reduce if possible, and all three of these numbers can be reduced. So we'll go ahead and reduce them. All three of those numbers can be divided by 4. So I'm going to divide all three of them by 4, which leaves me with negative 2 plus or minus 1 square root of 10 over 1. Now, you don't really need this one or this one to be written, and so the final answer would really look more like this. There you have it. Moving on to number 15. Solve each equation. Remember to check for extraneous solutions. All right. So for this particular problem here, we want to get rid of any numbers that are outside of the square root first. And once you have the square root all by itself, we want to get rid of the square root by raising both sides to the second power. The second power cancels out the square root and leaves me with just 9x. On this side, we have 3 to the second power, which is 9. And from there, we should have a simple equation to solve, which in this case can be done with just division. And so we have 1. Now, the problem says, remember to check for extraneous solutions. when it comes to square root equations, it's possible that the answer you get isn't allowed. It's called an extraneous solution. And the way that you make sure that that answer is acceptable is by plugging it into the original equation and seeing if it works. So let's see if it works. 9 times 1 is 9. The square root of 9 is 3. 4 plus 3 is 7. And this works. And the reason I know it works is because 7 equals 7. That's a true statement. And therefore, this is a good answer. So my answer is x equals 1. Number 17. This one doesn't have any numbers outside of the square root, but it has a square root on both sides. So to get rid of the square root first, we're going to raise both sides to the second power, which cancels out the square root. And now we're just left with a basic linear equation. And so how do we solve this? Well, we move the smaller x to the other side, or I guess smaller n. And then we just solve. And I end up getting -4 as an answer, but once again we need to check for extraneous answers. So I'm going to plug my answer into the original equation here, and we're going to see if we get a good answer out of it. So 2 times -4 is -8. -8 plus 10 is 2. Let's do the other side now. -2 times -4 is 8. And -6 plus 8 is 2. And once again, those two things are in fact equal to each other. So that means our answer is good. And my answer is n equals -4. Finally, we have the equations that we were working on last week, which is these equations that have fraction exponents. For these particular problems, what we do is we want to get rid of the fraction power, and the way that you do that is by raising both sides of the equation to the same power but reciprocal. So instead of 3/2, we're going to flip it over and make it 2/3. The reason we do that is because that cancels those out, and it leaves me with just x plus 3. But since I raised the right side to 2/3, I also need to raise the left side to 2/3. And now how do we do that? Well, we rewrite it as a root first. The denominator tells me what kind of root it is, and the numerator is a power that we raise that to. So that's the first step, is to do the reciprocal power on both sides. And now we get to take care of this radical expression here. So 512. Let's break it apart first. I know that 2 goes in there. Break that up again. I know 2 goes in there. I think it's just going to keep being divisible by 2. There we go. Pretty big number. So I know I went through that one a little bit quicker than you might have, but there we go. We end up with a lot of 2's, basically. It's like there's 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. All right. Well, we want to do the cube root of 512. So the cube root of 512 can be found by putting all those 2's that we just broke it apart into. We said there was 9, right? Oops. And we're looking for groups of 3, so for every group of 3, we can put that number on the outside. So I was able to find 3 groups of 2, and for each group I put a 2 on the outside. Now notice there's no more numbers on the inside, so we can just get rid of the radical, and we're left with 2 times 2 times 2, which is 8. So that is the cube root of 512. And that's what I'll replace this with here. Okay. Some other little detail to keep in mind is, don't forget, sometimes you have a negative in here, which we don't on this problem, but if this is an odd number, then you just put the negative on the outside. If it's an even number, then you would have 2 answers. You would have a plus and a minus. Okay, but we don't have to worry about that in this particular problem because it's a positive 512. All right, next we have 8 to the second power, which is 64. And then finally we'll minus 3 on both sides. And we end up with x equals 61. Do another one here. Similar steps. Raise both sides to the 3 over 2 power. These cancel out, leaving me with 6x minus 13. This side, we're going to change it into the square root of 25 cubed. Now, the square root of 25 is pretty simple. That's just 5. But don't forget that whenever you have an even root for these particular types of problems, you're going to make a plus and a minus. Next, we're going to cube it. So raise it to the 3rd power. 5 raised to the 3rd power is 125. So we have 125 plus and minus. And since there are two numbers there, 125 and negative 125, we're going to have 2 equations. One of them positive, one of them a negative 125. And you just solve both. I don't think it goes in there evenly. Does it? Oh, yes, it does. 23. Okay, and then the next one. I don't think that one goes in evenly, but we can reduce it. Oops. And there we go. All right. And that'll do it for today. So hopefully that was helpful, and we'll see you next time.